Okay. 2.3, solving multi-step equations. So this is, excuse me, essentially the same kind of stuff, just with more steps that we did last time. So, you can kind of think of it as being able to solve the equation is like working backwards, but not really. So what we're going to do is I am going to say it's like we're locking the x, but you can't take care of what's right next to it until you take care of the other stuff on the same side. So we're going to do the same kind of thing. Instead of having subtract 4 to move it over, we're going to add 4. So then we're left with 11x equals 33. Now we can take care of the 11. So then x equals 3. Okay, so then we have something like this. I'm going to go in a little bit. Okay. Again, it's really hard to take care of what's right next to it when there's other things on the same side. So we'll take care of that. So the opposite of minus 25 is plus 25 to get it to move. So now we have 2/3 p equals 210. Then we can take care of the 2/3, but remember that when we do multiplication, but then you can't. So we're going to multiply by the reciprocal on both sides. And you just need to remember that that has to be over 1 in your head. So then I'm going to switch back. So then this cancels out. So then we have p equals 210 times 3 is 630. 1 times 2 is 2. So then p equals 315. Not too bad. So next one. Okay, so again, we need to get rid of everything that's on the same side as the x. And normally I would say multiplication division would probably be second, but in this case, we can't take care of the minus 7 because it's closest to the x first, so we're going to have to multiply this by 3 and this by 3. So those cancel. So we're left with x minus 7 equals 27. So now we're just going to add 7. So x equals 34. So then, let's look at this one. All right, so this one's a little complicated, but not. This minus is actually attached to this right here. So it's an understood plus in front of here. So to undo it, we need to subtract it. So we're left with negative a over 3 equals 3. Now, there's multiple ways you can do this, but I like to attach the negative to the one I'm getting rid of, so I don't have to do another step. So we're going to say that this is a negative 3, so we're going to multiply by a negative 3 because it's being divided times negative 3. So then that cancels out. So A equals 3 times negative 3 is negative 9. We're going to go ahead and skip this one. So then we're going to talk about consecutive numbers. So anything consecutive, it's one right after another. So if I said I had pizza for 3 consecutive nights, that would mean that I had it maybe Monday, Tuesday, Wednesday. There's nothing in between, okay? So examples might be 1, 2, 3, or 97, 98, 99, okay? Then we have consecutive even or odd numbers. So we understand that evens are 2, 4, 6, or 10, 12, 14. So 2, 4, 6 would be considered consecutive even numbers because the numbers in between here are odd, so we wouldn't deal with those. So these would be considered consecutive even, just like 1, 3, and 5 would be considered consecutive odd because there's no odd numbers between them. Okay, so we have a problem that says find 3 consecutive integers or whole numbers with the sum of 21. So we've got sum. So that means 3 numbers are being added together, but we don't know what they are, and they equal 21. Okay, so because we have no idea where they are, I mean, they're obviously smaller than 21. Okay, so we could guess and check and whatever. But if you ever ended up with a question where there weren't whole numbers, it's really hard to guess like 2 1/3 or something. So it's best to kind of come up with an algebra problem to solve it. So if I said the first one is x, the next consecutive number is just going to be 1 higher than that. So we would have, so here's what we started with, plus 1. So it's 1 higher than that. And then this one would have to be 2 higher than that. Kind of like 1, 2, 3. 2 is 1 higher than 1, and 3 is 2 higher than 1. 97, 98, 99. Well, if this was x, to find this, it would just be 1 more, and then 1 more than that, or 2 more than the first one. So if we go ahead and look and see how many x's we have 3x, and then 1 and 2 put together is 3. So now we actually have an algebra problem that we can solve. So subtract 3, 3x equals 18, divide by 3, so we have x equals 6. So then our numbers, we would come up here, well, x is 6, and then 6 plus 1 is 7, and 6 plus 2 is 8. So the numbers are 6, 7, and 8. I apologize for all the coughs. Okay, so then we have another one. So we have 3 consecutive odd integers with the sum, same as before, of negative 51. So we have 3 numbers, and they have to equal negative 51. Okay. So we can still start with x, but if they're consecutive odd numbers, well, if we had 1, 3, and 5, to get from 1 to 3, we have to add 2. We have to add 2. To get from 3 to 5, we have to add 2. So to get from 1 to 5, we actually have to add 4. So we're going to add 2, and we're going to add 4. Excuse me again. So then putting our x's together, we have 3x plus, and then 6 equals negative 51 minus 6 minus 6. 3x equals negative 57, divide by 3, divide by 3. So then x equals negative 19. Okay, so then if this is negative 19, then if we add 2 to a negative number, it makes it actually look smaller, but it's not. And then minus 15. And so really quick, so if we have negative 19, let's see, negative 19 plus 17 negative plus 15 negative. So we have negative 51. The negatives over here. Okay, so then your assignment is this.